Hello everyone, welcome to another episode of 5G bite-sized video series where we are learning one or two 5G terms under 10 minutes or so, and that's why we are calling it as bite-size. These are unstructured 5G videos covering one or two terms. So today's agenda that what we will be looking at is what is vRAN, CRAN or ORAN means. We will be demystifying these terms, keeping a network beginners in mind, and I will try my level best to highly simplify this. So even if you are somebody who have not worked on RAN side, you will be able to understand what all innovations are happening on the RAN side with these 5G bite-size series. So with that, let's just demystify these acronyms first. What does the vRAN means? That is your virtualized RAN. Then we have CRAN, that is your cloud RAN. And finally, we have ORAN, which is open RAN. And now let's look at what these terms means. But before that, let's just look at a complete end-to-end 5G architecture at some 30,000 feet view and try to see where exactly our topic for today fits in. So this is a end-to-end 5G network, a block diagram where you have a radio access network, where you have your cell sites where radio antennas are there. Then you have your mobility core components that are deployed, and to interconnect these you have this transport network, and of course there is the spectrum piece, and then our favorite endpoints like your mobile phone or other type of 5G sensors, as this space along with 5G is also seeing a wider footprints of endpoints. But the topic that we are covering today fits here in this. Right? So now let's look at how does a typical RAN site looks like. So this is the picture that I took from one of the Cisco documentation where you have your radio antenna that is deployed with the baseband unit and then a cell site router. Without going into the functionality of each of these, this is how a typical cell site looks like. Now, if we look at 5G, that comes with promises of a very good bandwidth in Gbps and lower latency. Right? That means we need to have multiple of these sites to fulfill these promises. That means the providers will have multiple of such sites to deploy to deliver a true 5G service. But think from the provider's perspective that deploying these multiple sites in its current form is very expensive for them. Can we do some sort of optimization here that can bring down some cost and deliver an efficient architecture, the RAN architecture for our service providers? So that is where let's just take this piece from this slide and see what type of optimization can be done. So this is how a typical baseband unit looks like. Without going into the functionality of it, earlier the BBU used to be a purpose-built hardware where the relevant softwares were deployed. and this all comes from a single vendor. It's as simple as like you take a Cisco router and it comes with its own hardware and the deployed software. But can we decouple the software from the hardware like the way we have done in our virtualization? So the answer to that is yes, there can be any commercially off the shelf hardware, and then these individual software components can be deployed here, right? And this decoupling is something that is not new. Remember, I given a Cisco iOS example. Even now, you can take a Cisco iOS and deploy it on any white box. So when we virtualize this, definitely we don't need this purpose-built hardware, and this is something that is called as virtualized RAN. So this is first level of optimization. Can this be optimized further? Remember in our previous diagram where I was showing you a typical RAN site, and to deliver the 5G promises of high bandwidth, low latency, there has to be multiple of those sites, right? Now, when I have decoupled this BBU, can I take this BBU on this COTS server or hardware, let's say, and deploy it at some central location and connect multiple of these radio units to this, right? That way, I'm not hosting individual BBUs per site, and rather I am having it at a centralized location, right? That brings in another advantage for us, right? And some of you may be thinking now that where exactly this component is deployed. Well, this can be deployed in some SPs, smaller data centers, or it can be taken to the cloud as well, right? I can take this component, this part into the cloud and connect all my radio sites to this. And this is what is actually called as cloud RAN or CRAN as well. So now to understand what ORAN is, let's break some of the components for the RAN side. So this was the RAN side that we had seen in our previous video of bite size series. We had seen that this can be broken into multiple components like RU, DU, and CU. Now, let me ask you this. When I have broken this RAN into multiple components here, do I need to buy all these components from the same vendor? Well, traditionally the answer to that question was yes, but now with Open RAN, what we can do is, like, as these are the multiple components that you see are deployed on a commercially off the shelf hardware, that evolution we have seen with virtualized RAN. ORAN brings another optimization where these individual components can be from multiple vendors. So that gives another flexibility to these SPs. To further simplify Open RAN, it can be like assembled PC that you get from the market, where you can have a motherboard from Intel, let's say. You can have RAM from a different vendor. You can have your desktop from a different vendor, speakers from different vendor, mouse from different vendor, and that way you build a complete package that actually fulfills your requirements. Same way for Open RAN also, you have these components from specialized vendors and they interact with each other on some standard interfaces, right? That is defined by Open RAN. So Open RAN enforces these standards. To me, this looked like an amazing innovation, even the vRAN and the CRAN part as well that are happening along with 5G. But the concern that I have here is about the support factor for this, right? And that's where there are these OEMs that make much more sense to package this solution and provide support. And with that, let's conclude this video. So I hope this was something that was informative. You have learned something new. Thank you so much for your time for viewing this. Stay tuned for more such videos.